All right, so if you're given a problem where you're asked to divide a polynomial by another polynomial using long division, and the way that you would set that up is just like long division if you were dividing, let's say, like 64.3 by 5. Okay, if you set this up, you take whatever you're dividing, whatever you're starting with, the x to the fourth minus 3x cubed. Notice there's no x squared. What I would do on this is I would specifically write 0x squared to represent any missing terms as you reduce your power. So 4, 3, 2, 1, then 0, and with your constant, use your division symbol, your division bars, and you put what you're dividing it by, the x squared plus 1 on the outside. So you're setting it up just like you would long division by numbers. And once you set it up in this form, the process to continue this is going to be, again, kind of just like what you would do here. You see how many times does 5 go into this first term, this first digit, right? And it goes 1 time. So 1 times 5 is 5. And then we subtract that. We change the sign of it and combine down the columns. We're doing that same thing on the long division. So just look at the first terms, x squared and x to the fourth. What do you have to multiply x squared by to get x to the fourth? X squared, right? And now you're going to multiply. So here we took 1 times 5 and got the 5. Here we're going to distribute this. So x squared times x squared is x to the fourth. X squared times a positive 1 is plus x squared. So notice I wrote it in the same vertical column as the other same degree terms. Hey, once we wrote our 5 here, then we're going to subtract it, right? So we're subtracting this quantity from what originally started. So rather than thinking of it as subtract, just change the sign of every term. So subtracting is just adding the opposites. So we're going to change the sign or find the opposite of each of the terms, and then we're going to combine down the vertical columns. So the x to the fourths cancel, and now we're left with x cubed minus x squared minus 2x plus 1. Again, that's what we would have done here, and we would have rewritten our terms straight down. And so we wind up just continuing with the same process. So now x squared goes into 3x cubed how many times? Or negative 3x cubed? No. The top one's just numbers, and then these are polynomials. I'm just showing that the process is exactly the same as if you were doing it with numbers. Yes, this in black here is this one. Well, because it was missing that term, and so I just put a 0 in there as a placeholder.
Why wouldn't the x squared cancel?
Well, it was 0x squared minus 1x squared, and so that nets you a total of minus 1x squared. Okay. So if you look to see what do we multiply x squared by to get this first term, negative x or negative 3x cubed, and we choose a negative 3x, right? So if we distribute this negative 3x, you get negative 3x cubed minus 3x. Change the sign of all our terms. So this becomes a plus and this becomes a plus. Combine straight down your columns. The x cubes cancel, so I'm left with a negative x squared plus x plus 1. And do one final step, the same thing one more time here. X squared times what gives you a negative x squared? Minus 1. And so you're going to distribute that negative 1. So you get a negative x squared and a minus 1. Change the sign of these. And once again, when you combine down the columns, the x squareds cancel. You're left with x and a plus 2. Okay, now notice there you can no longer multiply x squared by something to get x. This is now a lesser degree. So that means this is your remainder. So your remainder is just that entire expression, x plus 2, over what your original divisor was, x squared plus 1. And so this would be your simplified form after the division. All right? So like I said, you guys aren't going to necessarily need to do this by hand. I just want you to have seen it, and I'll show you one more example of it here, but you don't need to do it by hand unless you don't understand how to translate what your calculators show. Okay, because here's what you're going to be given. Hey, if you were to enter this on your calculator, and I'll show you how in just a bit, you're going to be given a form that looks like this. Okay? It's going to be an expression plus some remainder. Okay? When you use your calculator, and again, you may want to leave some notes to yourself to explain how I'm doing this. Okay? You simply are going to divide. You are going to use expand. Okay, so we're going to access the F2 Algebra tab, choose expand, and then we're going to type in our division. Start with the top number, what you're dividing into. So here we get x to the fourth minus 3x cubed minus 2x plus 1. Again, we didn't have to enter the 0x squared for this one. And we're going to divide this by the x squared plus 1. And we close off the entire operation for the expanding command. Okay, once I hit enter, you need to be able to interpret how to display this expression. All right, so when I hit enter here, okay, notice the way that the expression shows up on your calculators. It's going to be the same as what it has here. And notice that it has this little arrow head pointing to the right. Okay? Disregard the fraction part to start with. Okay, we'll come back and talk about that later. So you need to scroll over. Okay, and notice what's to the right of the fraction. So once you get past the fractions, you see x squared minus 3x minus 1. That's going to go in this first part. X squared minus 3x minus 1. Notice that's the first part of our answer, right? Okay, now the next part of your answer requires you to manipulate the remainders a little bit. So here's the easiest way to do it, where you don't have to do too much other than follow your own directions. And so first of all, does everybody see how I got the first part of my answer here? All right. Once you get that first part of your answer, what I recommend that you do is clear your display and then go up and highlight the answer that it gave you. Once you highlight that and pull it into your display, I want you to delete the entire expression that you wrote in this first part. So delete the x squared minus 3x plus or minus 1. Once you delete that, just hit enter again and it should simplify that fraction for you. So now this is your remainder, x plus 2 over x squared plus 1. Okay, so it should be that simple. And now, if it's not, you might have to go through one more step on your own, and that is this denominator of your remainder should be exactly what you're dividing by. So you should be able to fill that in even before you enter the problem in your calculator. So the remainder should be x squared plus 1. Okay? If you perform this step and there were still two different fractions in the denominator, what I would then do is take that display that you just did and multiply it by the entire expression that you originally divided by. So if you took that expression, whatever was here, and you multiply by the x squared plus 1, and then hit enter, it's going to give you what goes in the numerator. Okay, so if you still got multiple fractions in this step, just multiply that by the original divisor, and that's going to be what's written in your numerator.